Thanks again for your flexibility. Months ago we made the commitment, and actually being able to be here is good. Being able to make a commitment is a minor milestone for us these days. So thanks again, Pat, and the flexibility. All right, so one of the things that's come up when I've been talking to people is it's already been enough time, over 20 years since DCX, DCXA. When I talk to the young engineers, a lot of them don't even know what that program was. They think vertical landing vehicles is something that SpaceX and Blue Origin have developed sort of out of whole cloth. And then I give them my little spiel, well, and then people will see pictures and go, well, that's what they're doing today. It's not quite true. They've really taken it. But that program, and I'll get into it, really there's a lot of kernels of seeds of technology that built on earlier technology from Thor and other programs, Delta, and is propagated through into current programs. Now, as I started going, I filled this up with a lot of pictures, so I'm not gonna talk too much about other folks' programs as much as the ones I've been involved with. I will say I am still with Vector, but I'm not here as a Vector person. As you know, we're going through some challenges right now. I will say a couple things just because I've been getting a lot of questions, so I'd like to take this out of my question budget, but just to clarify a couple things, because of the rapid change in our finances in August, we did have to go through a series of reductions in force, of which the most significant was on August 9th. We did not eliminate the entire workforce. We were able to retain a small core of dedicated people, and we did not lock the doors at the time. And those folks, the goal was to try to evaluate options for continuing and try to do right by our stakeholders. And I'll just say that is still our objective. We are still working hard at that. And that's why I'm a busy person, because we are trying to work a number of options. So I'll leave it at that. We wanted to say more, but I'm learning a lot from my lawyer associates and others, and I'm learning a lot about stuff like the Warren Act and what you can say and can't say. So that's why what you'll hear today is going to be more about launch vehicles and sort of the thought process that's gotten us here today. So here we go. Let's see if I push these buttons right. Okay, this is what's in the agenda. So I'm going to talk about the DCX. Let's see if this part works. There we go, cool. The DCX, Delta Clipper Experimental, and also the second phase, the Delta Clipper Experimental Advance. That's DCX-A, which is when I was involved. And that was sponsored by NASA versus SDIO / what was BMDO and other names. So I'll talk about there's a lot of good words here, but I'll move on. So if you aren't familiar with that, there's the DCX on the left, there's the DCX-A on the right. And the reason I know I can tell the difference is this is one of those lessons learned that you don't get in rocket school. But if you see here, it looks like there's some logos that might have been there once. And there were. And they burned off after the first flight, which people didn't appreciate. So when we went out on XA, oh, there we go, I'll push it back. Let's see if that works, goes back. There we go. We took the logos off so they wouldn't burn off. Little lessons learned, but that's what you get by doing things multiple times. So again, if people aren't familiar, 4RL10 LOX hydrogen engines, which people were amazed to see these operating out in the desert and being reused. They'd come back and be full of moisture. There's gypsum out here. That's why it's called white sands. And what they would do with the new engineer when you showed up, your first job was they would give you a shovel. The techs would do this. And they'd send you out to the pad and say, all right, go shovel the gypsum that accumulated. And it was really important because you'd watch the techs and they'd wait and see and say, if you went and you shoveled it, all right, well, maybe let this engineer, we'll evaluate him. But if you said, I'm going to go back to the donut trailer, which was the nickname for the command, air-conditioned container up top, they put you in a different category. So there was a lot of lessons learned for those of us who are young engineers. And what I'll say is this type of program is what we need. I get these 5, 10, 20-year programs, but you need to have these programs that are fast, you take risk, because that's how you transfer the information from the older generation to the next generation. I learned a lot from Delta and S4B veterans, which I'll talk about, that you only get when you're standing on the pad and Conrad's talking to you on the headset, and Bernie Theaters, who's an old hand, is telling you, what he thinks of hydrazine and other things, and you go, okay, and then you see it in operation there. So anyway, this was in the mid-90s, And so the DNA I think about goes all the way back to the Thor intermediate range ballistic missile, which was implemented in 57, 58 as an alternative, as a gap filler, because the Atlas and the Titan programs were behind schedule. So they went to put out an RFP, and Douglas came back, the aircraft builders who knew how to build a lot of airplanes, the DC-3 and that stuff. And I think it was a 1-month proposal. And if I got my dates right, I think it was 57 to 58 or something like that. 1 year, they went from start to having a vehicle on the pad, which is pretty amazing. And that evolved into the Thor Delta, which was after Able, Baker, Charlie. They started stacking upper stages on top. And Delta happened to be a small launch vehicle. That seemed to hit the niche. NASA took it over. It became Delta. So that's the trend that happened. And then Douglas got the contract for the S4, and that became the S4B. Again, iteration. You know, I'll get a little more. Delta 2 came along, Delta 3, 4. I've highlighted. So Delta Clipper took the heritage of this. That's why they were able to move fast, because there was an infrastructure. You could take the best techs. You could go rob the Delta program if you needed fasteners or you needed a pump or a valve. They could go over, and Dave Schweikele could cut a deal with the program managers and make something happen. So you had to have that infrastructure to do this type of stuff. The bold ones are ones I personally was involved with. So I was at the tail end of DCX. I was a flight engineer, spent 5 months out here in New Mexico in Las Cruces working XA. I then came back after the crash, worked Delta 3, 4, went on my own, supported Jim Mazer when he was running Sea Launch. And then as I say, I was involved in the precursor that led to Falcon 1. I'll talk about it. And then these are vehicles that I've been associated with, but they're in italics because they haven't gone all the way yet. So that's the DNA train. Now, you can go here and say Douglas became McDonnell Douglas, became Boeing, became part of ULA. There's a separate theme, which you go to Lockheed, which was Martin Marietta, which was Convair, which was General Dynamics. And I was going to do all that, but then I get real dangerous because I know a little bit, and a little knowledge is dangerous. So I'll stick to what I know for today and sometimes make a passing negative remark about the other guys. So this is the Douglas plant when it was set up, I guess, around 1964. I like this one. For those of you who've been out there, you might recognize this. There's the quad where the engineering was going on. This is where they did S4B. I think there's another building. This is where we built the DCX back here. And over here, for about 30 years, was the 8-story Building 17, which is where we managed space station. When I first got out there in '86, they were just starting to break ground. They built that. That was the new building. Well, if you've been out there in the last year, they tore it down. If you want to feel old, go and drive by twice a day a building they're tearing down that used to be the new building 30 years ago. That drives it home. I will say our vector is right over here. I first drove up right here when I was a young engineer. I said, how do you beat a place like this? They got thousands of engineers. They know what they're doing. A year later, I was like, how does this place stay in business? They got 1,000 people. They can't decide what to do. They don't know how to do anything. It's sad, though, because this is phasing out as we go on. If you go here about 3 miles across Seal Beach, if you know that area, it's now sad. Since the Apollo 11 ceremonies, they are now tearing down the high bays where they built the S2 stage for the Saturn V. So you're watching every day as that's come down. So we lost, I view that as a historical monument. I guess as a businessman, you go, okay, fine, it hasn't been used probably in 45 years. But anyway, it's kind of tough to see these signs of aging happening. My bio, just for the record, I came out, I actually started RCAS Electronics in New Jersey, which is now part of Lockheed, which is closed there. I came out to McDonnell Douglas in '86. I'm a McDonnell Douglas guy. Even though I was there when Boeing bought it, I never became a Boeing guy. Sorry. And then my peers, it's amazing the number of people who are there. I just got tired of writing names. Tom Ingersoll, if you know him, at Skybox. USN went off with Pete. Sold it to Google. Dan Hart, now running Virgin Orbit. We used to beat each other up on Delta IV programs and then go have a beer afterwards. Jim Mazer, he's over at Rocketdyne now, past president of AIAA, ran Sea Launch, that's when I was there. Jim Simpson, he was at Boeing. He's now got a new startup going. Kirk Preischer, ILS. Paul Gehry ran X-37. Greg Jones, Frank Slazer. Frank was out in Washington. Some of you may know him. They're both with Jim at Aerojet. Greg Laboda, Dave Burnett, probably not as well known. Keith Dayton, but these guys I work with. Dave has his company. Keith ran 18 launches, Sea Launch. This is just a subset of what was there in the 90s. And they're gone. And I look at a company and say, you lost this talent. That's amazing. It's unbelievable. That's that DNA that we all picked up and took to the industry. Then there are the senior mentors. I didn't put their names because they might get it and then they'll still be mad, even though they are my senior guys like Schweikley and a few other folks. But I'll include guys like Pete Warden, Mike Griffin, Bill Gaubatz. And I was there when Bill sold the DCX program. I was a young engineer sitting in the business review, periodic meetings that Chuck Ordahl would have. And Chuck Ordahl said, all right, Bill, you can have $100,000. Don't spend a dime more than that because this program's never going to go anywhere. And Bill said, okay. And then he walked out and blew through the budget. And we were like, what? And then we had to give up our IRAD dollars. But he won. So, as a young engineer, there were a couple of lessons. If you win, a lot is forgiven. And even if you stay on budget and on time, if you lose, it doesn't matter. You lost. So I'm not sure those are the lessons you want to be teaching young engineers. That's what I got out of it. And what I kind of feel is like I'm the Forrest Gump in a way of the rocket business, because I've been at a lot of these things where I've been in the back of the room going, wow, that's interesting. And then 10 years later, you go, hey, that was a pretty significant moment. I left in 2000 because Delta IV was going to go to the Cape, and I didn't want to leave my wife again for another year or so. Like I spent 5 months here. I had to use a lot of points on the home front. So I went off. Jim Mazur was Sea Launch. I worked there. Blastoff was a .com. Musk Foundation. So I supported Elon in what became SpaceX. I did not join SpaceX, but we were there in the formative days. That's when Jim Cantrell and I were working a lot together. Space launch, Orbitech, we flew some stuff, a lot of DOD and NASA, that's what kept us open. And a key thing is, you can't see it maybe, but I worked with Cal State Long Beach. Eric Besnard was a professor, and he was really my partner in crime. If you know Eric, he's the one who worries about all those figures after the decimal point, where I'm the guy who's like, is it 1 or is it 10? I just got to know that much. All right, so here you go, DNA. I go back to the late 50s. This is just a subset of vehicles that were developed and put out, so you have the Juno, you got the Vanguard, my favorite, the Thor Delta, the Scout came a little longer. Don't forget, at the same time, they were doing Atlas and they were doing Titan. So, and they were doing, getting ready with the solids shortly afterwards, the Polaris. So that was all going on in the late 50s. So they were able to put these out in a matter of just a couple of years. And these were nanosat launchers. So that's what we went back to. So I said, if these guys could do this with 1958 technology, we should be able to try to learn something from that. So you look at it, really stripped down infrastructure. You don't have a big, mobile service tower, everything else. That was the heritage that we looked at. Payloads, these are nanosats. And this one happened to find the Van Allen belt. It's a fairly significant geophysical phenomena. And Vanguard is actually still up there. So there's a lot of good stuff that you can do in small packages. This is also a neat one I look at. This was a secondary payload. This was the first amateur satellite, Oscar 1. This was put on the side of a Thor, and that's what led to rideshare. So if you want to go back to rideshare, go look at these guys up in the West Coast, because that's what the precedent was. And so going back to Thor Agena B, that's to me the reference model. So you look, strong back, part of a transporter erector launcher, nice forklifts. And I'll also point out, for Mike Roberts, this is something I look at and say, hey, if you really want to have dedicated microgravity missions, go up and bring capsules back. Terminal Velocity was looking at it. And now you know when you go, you can stay up there for a few weeks, you don't have to wait for the Dragon capsule, and you come back. Again, this was done in the 1960s. Now, how can we change that? Well, you don't have to have a, specially modified KC-130 or H-130, whatever it was, or Boxcar 119, C-119. You put that on UAV, put on ADS-B, and you've got a much simpler recovery thing. So we were starting to look at doing an end-to-end. You launch out of Kodiak, you come in over Poker Flat, you recover it, and you bring it to University of Alaska Fairbanks within an hour, and you have your samples. I think that's how you then learn with what you guys are doing on Space Station, and then that's commercialization. But again, this was being done 55 years ago. Also, you look at it and go, geez, can you put a bigger stage that way? And I see Rocket Labs following that. If I was going to do reusables, knowing what I would do, I would try to do this. John Kelly's here. He knows all about that. There you go. We've talked many times about it, that this is the way I would do reusability. So that's our basis. So you look, here's a typical Thor Agena. And this is what we were doing at Vector. And if it looks similar, there's a reason for that. Now, I will say, this is at Vandenberg. All right, we also did it, Mark Greby's in the audience. We did this up at Kodiak. We've done this at Wallops. We've done it at KSC. Actually, it's Cape Canaveral. and we did it at Spaceport Camden. So we demonstrated that this type of architecture is totally doable for a small company. Going on to some other stuff, I just mentioned the DNA. This is the S4, and the reason I find this significant, it had 6 RL10s. Not 4, but 6, all right? And then, but it wasn't, they wanted to go different, and there's a number of reasons, so they went to the S4B with a single J2. I mention this because I learned a lot from the guys who did the insulation. This had internal insulation. That was one of the things with the composite tank on the Clipper. So this is when NASA took it over. There was a number of technologies, but my time's running short, so I'll talk fast. But they squeezed a lot in, which is a problem. I hate to say it with NASA. You guys try to squeeze too many technology experiments on a single mission because it's your only chance. Instead of just picking 1 or 2 and say, let's just do one thing, and therefore the variables are much more controllable. It becomes exponential when you try to squeeze a lot of experiments on. But in this case, where I had experience was a little bit of the sensors, and then as somewhat of an observer on the composite tank. So this was over in Huntington Beach. I won't get into the details of it, but I will point out Carl Emmon was probably about 80 at that point, and he had worked the S4B. And so I learned a lot by being in the room with him. A good example, we put internal insulation. That was the whole thing instead of external. So that orange foam you see, which is damaged, suspect to being damaged and all that stuff, by putting it inside, it's much more protected. That's how they did S4B. And they did it all, but when they got to certain things, they put cork, if you were near tough fitting, instead of doing the foam. And I asked Carl, why'd you do that? He goes, we can never figure out how to make the foam work. So we just put it in the cork. I said, well, you cheated. He goes, yeah, but we were in a hurry. Now, if that had just been me and I didn't have that knowledge, I'd be telling my young engineers, you got to go make that work. You got to find a way to work, and we'd spend 6 months trying to fix it. These guys didn't have that pride. They just marched and did it. Carl also, I think, bought everything from Ace Hardware here in New Mexico. All right, so he was my role model that you could do this in a garage. The other thing I learned, this is when I first learned, if a technician is willing to let an engineer do something, you don't want to do it. In our case, the technicians were quite happy to let us young engineers crawl into that manhole cover and apply the insulation and then put the linerless or the polymer liner, the polypropylene. That was the magic design there. And we'd be in there, and the techs would stand out here, and they'd have an air conditioner and towels. And their job was, if we passed out, was to go in and pull us out. And when you're in there, you kind of go, wait a minute, what's going on here? But anyway, but that's how I learned a lot. This is us out here and at White Sands. That's me, and I was supervising. They wouldn't let me play with the Bobcat, but we had to build the trenches before you could work in the trenches. And Kenny Berdino's either here or here. I can't tell now, but he's still working with us to this day. So if you look at this, this is what I'm used to. This was my formative experience for what you need for infrastructure. You're out in the middle of the desert with gypsum sand where it gets to 105 degrees, and those big storms roll over at night or in the afternoon, and when you come home, there's gypsum everywhere in your clothes, and I mean everywhere. And it also meant to the rocket. And yet, we were able to launch this thing a total of 12 times. So that's my reference point. There again, they let me do stuff like mix paint. That was my skill set. It's like, okay, fine, I'll do that. They also let me scrape the charred ablative. That was the other thing. And what I learned is don't get downwind of the tech because you get all that stuff coming in your face. But a lot of lessons learned that doesn't show up in textbooks. So what happened was we were there, and I went to Dave Schweikely, our program manager. I said, Dave, we're going to build this composite tank for X-33. It's going to be the size of this room. Why don't we build some small ones and go fly it? Because all our composite guys had different options. And Dave said, Garvey, if that's such a good idea, go do it yourself. Now, go get my rocket ready, which was a perfect response from a program manager. Go do the tactical near-term job. Don't be wasting my time on other stuff. So I walked out of the room, said a few swear words, very quietly though, and I started building my own rocket. I started designing it at El Paso Airport while I was waiting. Mike Navratil, one of the techs, started going, that's crazy. When do we start? Long story short, this is Kimbo 1. There's Kimbo 0. And the reason it's called Kimbo is because my wife was on space station for 18 years. She started in 1984 when it was just for the Phase B proposal. It was 18 years before her S0 segment went up. I lasted a year and a half on space station. Said, this is going to be a 10-year program. There's no way. So, I have problems with programs that say it's 5 or 10 years, and then they're going to stretch. I was around during SEI, Space Exploration Initiative, in 1990. I was around when Bush 2 came along and said, we're going back to the moon with Constellation. I couldn't do that. But she stuck it out. I give her credit. But being an aerospace person herself, She came home and the garage is full of rocket stuff. She's like, can't you get enough of this at work? I said, well, honey, I was thinking of calling the rocket after you. And she went in the house. And I said, there's no way that just worked. I got to use the garage. I couldn't believe it. And a couple years later, when we worked with Cal State and changed the name of Prospector, she finally showed her colors. She goes, wait a minute, you're not calling those Kimbos anymore? And I was like, oh. The problem was all the other spouses wanted it named after her. And I was like, hey, I'm the boss, so tough. Anyway, so that was the first rocket. And I will say these 5-inch sections were salvaged from El Paso, from salvage yards. When I'd fly home back to Huntington Beach, well, I found out those are awfully hard to get through airport security. So I had to depend on techs to drive them back. But this was built in part here while we were waiting for THAAD missile tests. And we had downtime. The techs would help me out. And so a key thing, there you go, Mike Novato there, Tom Mueller of SpaceX fame. And these guys are good at telling me what I'm doing wrong, all right? That was one of my best attributes, I guess, is I would scare the heck out of people when they would see this, okay, that I'm touching hardware. And in this case, it's like, is it the blue wire or the green wire that goes here? And the techs would jump in right away and say, Garv, we'll take care of that. But this is the fun stuff. This is why I got in the business. There's Kimbo 2, which we're flying. This is at the Mojave test area. If you don't know the area, it's outside of the spaceport. This is a scene for a lot of technology development that people aren't aware of, or it hasn't got as much credibility. It's evolved into nearby the FAR, Friends Amateur Rocketry site. This is also where Virgin Galactic flies up overhead, and unfortunately the accident happened right about here and landed over there. This is us. So when I went off on my own to Schweikely, I wanted to fly the first composite tank, so I did that. I teamed up with Microcosm, Bob Conger, Jim Wirtz guys. They had a tank, they loaned it to us, our team put it together, Kimbo 4, we flew. Flew the first composite LOX tank. We would have been happy, my wife would have been happy if I said, forget it. Instead, I started having too much fun. This is in my garage. We migrated to a shop. This is the one that Elon came by and looked around and said, Jesus, these guys are crazy. You mean you can build rockets in this environment? So he actually saw this rocket, the BR-1. This was Tom Mueller's rocket. It was the BFR. Elon then took that for some of his rockets. But this is what we were working. That's what we did, a lot of technology development, even in that environment. And after we flew the composite tank, we said, what else can we do? Well, let's look at X-33 again. Hey, they tried to fly an Aerospike. They tried to put it on an SR-71. Let's take an advanced rocket, put it on the back of a manned system. Not a good idea. Didn't work. Then the program would cancel. So we built a very simple Aerospike. Eric Besnard led that design. Mueller helped us. We put it on the Prospector 2 at Cal State. We flew the first Aerospike engine. Flew it twice. Lesson learned, don't go refly it again. Save it. There's a little bit of historic stuff. We flew it as a Prospector 4, crashed it. Now it's gone. All right, NLV concept. I got 2 more minutes. Try to convert this into an operational system. For commercialization, you have to have a commercial pull. It can't be a push, all right? I won't go into it. We went to Cal State, started building bigger rockets from the small ones that would fit my Ford Explorer to something that now made sense. A lot of young engineers. Now you're starting to see this. We started getting contracts. Pete Warden helped set this up. We did a demo where we went out to San Nicolas Island. When you talk responsive launch, we had 3 months from the time we got to go. We went out there and we then flew a rocket after 3 days on site. 3 months to get the regulatory, 3 days to go fly. Then we went and started doing more composite tank work, TRL-6 for the tanks. I'll just move on. Got it into flight. There were problems there, but we did fly. LOX and ethanol. This is the Prospector 18. This is a reusable suborbital rocket. We didn't go high, 15,000 feet. But if you're trying to do academic stuff, that's fine. And we use parachutes. And apparently parachutes don't count for reusability for some folks. But we did fly it 5 times. And we flew a number of payloads. And the students loved it. For them, whether you go 10,000 feet or 100 miles, it's pretty much the same experience. They would rather get 3 experiences in a year than 1 every 3 years that they're probably not even going to be on. And there's a group from Cal Poly SLO. They got their CubeSat back. They're pretty pumped. There's Big Daddy, Garrett Scrobot, if you know him from the CubeSat launch initiative at NASA, our customer. Those guys are psyched. Then we switched to LOX propylene, testing out of Mojave. And core elements, I've got 3 seconds. I'll just say, so we came up with our design. A lot of lessons learned. I'll say no ordnance, 2 stages, composite tanks, a lot of stuff. Vector, I'll just take 1 more minute. We transitioned. We were able to start fast because we took stuff out of the shop. We went really fast, took a lot of risk, okay? Put these vehicles together, launched them. started moving into production of composite ones. It's pretty cool when you have your shop in Huntington Beach and you go vertical with this in the parking lot. Get a lot of questions. We did this at Cal Poly Slow, did that in the morning. Again, people get disappointed when they find out we're not going to launch. I tell them we can only do it once. That's us doing engine testing. I will say, even after we shut down, or not shut down, had the big reduction, we were able to go out. I challenged some of the guys who were left, and we got full duration burns on this. We need 150 to 180 second burn. We got, on this engine, we did 65 seconds and ran it for 145, so over 200 seconds. So we had an engine, we had to tweak it, put extra boundary layer cooling, performance wasn't there. That's what you do. But we're on the verge of engines that are getting to what we need. LOX propylene, spark igniter, a lot of stuff, 3D printed injectors. The TEL is now another generation TEL. This is us out in Arizona testing it. And this is us testing in Mojave. And then we went to Spaceport Camden. 2 months from the time we said, let's go, we flew under Part 101. George Neal, thank you very much. Your guys did what they had to do. I don't think this is what they meant when they said the amateur exception, but we went right up to the limit of that, and their guys said okay. And that's the type of support we need from a regulatory environment. Be flexible so we can do this. And you talk about bare bones, this is what's out there, Spaceport Camden. Also some alligators. I have some great photos of alligators and snakes and wild boars, fun place. So this is the vehicle we currently have, all composite, tanks, everything, built at Huntington Beach. And we had it to the point where we were on the vertical test stand, had been doing tests, getting ready to do static fire tests. That's what we'd like to be able to pick up again. There's us, that's our mock in Huntington Beach, Mission Operations Center, so you run it from Huntington Beach. And this is the launch control panel that if I'm ever a launch director again, I feel like maybe like Chris Kraft, they really won't let me do it again. But I want it launch, abort, and then they added a help button, and the joke is only the help button works. So. Okay, so there.
Thank you.
That's the DNA of one launch and where it led to a modern company, which traces back to DCXA.
So we have some questions here, and I'm going to combine two. How much seed funding do you think is necessary for a rocket startup? And then there's another question in here about people. I mean, how many people, what is the number of people that you think are critical for a rocket startup?
If you're really, we grossly underestimated, Eric and I, before Vector, what we thought we would need. We had plans probably for 40 or 50 people, and I think if you keep it lean and it's a team that's already functioning, you can get away with that, but it's got to be a team that knows. And part of the problem when you do a startup is you're building the team at the same time you're building the rocket. And so a lot of our challenges at Vector was how do you go from a group of 10 or 15, which is what I had at Garvey spacecraft when we merged it into Vector, to a company that has 150 people and it was at 3 different sites, and you can argue whether that was the right way to go or not. So a lot of it was just building the systems. If you already have an existing team, I'd say 40 or 50 people if they know what they're doing. And the money, I still think it's a big variable because a lot depends on risk. When it was my company, I could take the risk personally. You know, when we did some of those launches, it was me overriding the abort button or hitting the main valve open when I saw smoke. And a lot of guys weren't happy with me until the rocket launched. On the other hand, if it blew up, I owned it. We don't have that freedom anymore. We have investors. So if you have your own money and you're willing to take a lot of risks, you can do it for a lot less. That's how we used to do it. Now, if you add in, you've got to go fast but not have risk, then the number goes up probably by a factor of 2 to 4. So I'm just going to put relative. I used to tell Pete Warden that. I said, do you want a government program or a commercial risky program? If it's a government program, double the money, double the time.
Scaling is, it's an organizational problem, but there's a question in here that has to do with that, and I think I know the answer. What keeps you going forward in the rocket business? Where do you ultimately want to be? And P.S., why didn't you join SpaceX in the early days?
Why didn't I? 2 reasons, maybe 3. I didn't see the business case for going big like that. I thought there was a niche for small. We pitched the small launch vehicle to Elon, to Bezos as well. And they wanted to go big. They've already been big. As Mike Griffin was there in a meeting with us, and he said, even if you launch 100 times and $1 million a piece is $100 million, that's too small a market for Elon, even at that point after PayPal. If you want to go to Mars and launch people, you need big. And I'd already been on 2 programs, Delta 4, Delta 3, which were broken because the underlying business assumptions weren't right. So I didn't share the enthusiasm he had for the market. And then also, Elon's Elon, and I just decided I want to do my own thing.
That would have been fun to watch for a while, but so the idea, where do you want to be, this sweet spot, this niche that you believe in?
I think there's a niche, there's certain niches in there, and I'll just say this, for the VC world, you have to show the biggest, the one that has 100 times response, because that's what their business case is best on. There's ones that are smaller, that have smaller rates of return, but are probably more sustainable, that I think if you can get to those and maintain a business, you can then grow into the bigger market. So that's part of what I'll just say, we're trying to look at is there a business case? It isn't exciting. It's sort of like building the railroads. The railroads to me are a fascinating reference of what is relevant and what isn't. The railroads themselves, when we crossed the country, weren't where the money was. It was in the gold, it was in the forest, it was in the cattle. That was at the end of the railroad. The railroad was an enabler. And I think that's what launch is. Launch in and of itself, you're not going to make a factor of 10 or 100. But if you do a microgravity payload, you take it off the space station and commercialize it, and now you get that billion-dollar killer app, you need the launch. So the launch is really the railroad in the sense to doing the commercialization. So to me, if I had a lot of money, I would then be playing in those secondary markets. But I saw we need to build the rocket first in order to do the markets.
So in terms of being that enabler in the transportation industry, I don't hear humans in this loop.
No, humans to me, if you're talking commercialization, humans, there's a business case. It's like climbing Mount Everest. There's a business case because people want to go up there. There is no value added to having people at the top of Mount Everest. And I've said this in other stuff. I think if you want to explore, if you want scientific return, we've already demonstrated since 1970, it's much more cost effective to go to Mars or other places with robotics. And I hate to say it, putting a command center, where's Mr. Ken? We don't need to have a command center in low lunar orbit. It works perfectly fine on Earth. It was educated me on Mars. You don't put people on Phobos or that stuff. It's much cheaper to keep people here, and for the price of a single Mars mission, you can send probably 20 Mars rovers and put them down and put them in risky places, and you can do that in the next 10 years. So if you want to explore, if you want to get science, if you want to learn about these places, you send robotics. There are other reasons for doing it, but let's not say humans are part of exploration or science. I buy it. There's other reasons, but you got to have the right systems engineering. Is why are we doing it? Like I look at the moon architecture. You opened it up. I'm sorry. We're trying to build in scarring for Mars. We're not going to go for Mars for 20 years. We just heard that. And I heard that in 1986, and I heard it in 1990, and I heard it again. So we're going to design an architecture that might use LOX methane engines, because you want methane for Mars. Storables work really good at the moon, and they also are very reliable. You turn the valve on, they light up. So if you came to me and said, Garv, how are you going to get to the moon and do it quick? That architecture is not one that I would be building. Okay, but again, I'm a fringe player, so I don't, I'm a guy from the side. But if you said you got to get to the moon in 5 years, that is not the architecture that I would be building to get there. But anyway.
So this niche market, this market that you want to be in and get it to the point where it will be sustainable.
Right, that's the key word.
Why are you still using LOX? What's up with LOX here?
LOX?
Why stick to LOX?
Liquid oxygen, because it's the most, it's just from an oxidizer, it's easy to work with, you can get it. Nobody, when I first started, people were like, oh, LOX, you got to worry about it. LOX, everyone uses LOX. Hospitals have it, airplanes use it. LOX is a lot easier. I had a discussion last night. People start off thinking hydrogen peroxide might be good and other stuff, but at the end of the day, LOX is just the oxidizer. You can have variables for propellants. I do like storables. Ethanol is great. You load it up. We were talking about RP1 is good too. So I'm willing to give some ground on the fuel. You go to a cryo because of performance. But LOX is just a no-brainer for my.
So in terms of this niche and in terms of availability, and so what you're looking for is that your supply chain is relatively stable then as you're moving forward.
Well, we built a rocket that it's like the complex but simple. It's like your iPhone, or it's like losing weight. The concept is simple, hard to do. Eat less, exercise more. But that's hard to do. And so we were trying to build a rocket that was going to be simple when we were done. So we got rid of turbo pumps. All right, some of our competitors are going the other way. They're building very complex electric pumps with batteries that you have to hit the performance. But if we could get our engine to work at the performance we need and get the mass right on the tanks, our vehicle is going to be very simple. So that's how we were trying to cut down the cost. And by using propylene, it gave us a little bit of extra performance improvement and density that was going to help close the case. But it's sort of secondary to making the money. It's all the other stuff that really costs money. I can tell you, George, I'm sorry, but the licensing is really the hard part. When you look at those regulatory requirements, we had a lot of people working on it. They make sense, but there's a lot of stuff when I talk to these young engineers, they have no idea what they're getting. Try talking to insurance people. Frederica's going to come up next. She can tell you all about that side of the whole regulatory stuff that you can get all the math right, but then find out that your paperwork isn't there and it's another 2 years to fly.
So all of the skills that you've had to develop, the engineering skills, the human resources skills, then you learn about licensing and insurance and all of this. When's your head?
I'm still working on the human resources one.
Yeah, so this, in terms of the questions here, this last one, he ain't dead yet, but I'm going to ask you anyway. As you've witnessed historical moments in the space industry development, what are some of the things you wish you had done or done differently? 1 minute.
That we done differently? Well, I didn't personally go up to Silicon Valley because I didn't know how to do the math up there. It's a different math. All right. I'll give you an example. We walked out of one investor meeting and one of my colleagues said, we got to get a TAM of $1 billion. I go, what do you mean with the TAM? Total accessible market? He goes, yeah. I go, well, that's like 500 launches a year at $2 million a piece. I go, we're never going to launch 500 times a year. And he said, yeah, but they're going to assume you're overestimating because that's what all entrepreneurs do, so they're going to discount you. I'm like, well, wait a minute. I got to figure out how much they're going to discount me and add that on for an uncertainty factor. He goes, yeah, because if you come in with your straight number, they're going to discount it, and then the business case won't close from their perspective. So it's that type of math. And I get it. It's just intuitively, I'm not built for that. I don't know what. And the same thing with marketing and brand development. I'm the type of guy, I used to hear Hewlett Packard's marketing was sushi is cold dead fish. I'm like, well, yeah, actually that's useful information, Not the best for branding, and I get it. It's just I'm not the right guy for it. So that's why, I had to work with some other folks who were more comfortable, who spoke that language. So for me, maybe we could have gone out earlier. I don't know. But there's a number of things that, you go back with lessons learned, and in hindsight, you say, if I get another chance, I'm going to do it differently. I could give you an example. I was putting the charts together, and I was looking at our first TEL and the second TEL. Our TEL now has everything on board, all the propellant handling electronics, because we want to put it in one place. It's complicated. It's more complicated than the rocket. And I'm thinking, you know what? It might be easier to put it back on a separate module and keep that first TEL, the mechanical part, separate, so I can work the two of them and do it differently. So if I ever get a chance to build another launch infrastructure, I might do that again. So there's a lot of things like that, lessons learned that we would take and bring to the table. But it's that iteration process. I think our business needs to be able to get back into have a quick feedback cycle so that when you go up there, if you do go out, I keep going microgravity. You go up there, and I talk to Pfizer, I talk to Merck. Their problem is they don't know when they're going to come back, and they don't know if it's going to be 3 months when they get a ride on the Dragon or if it's going to be a year. We got to get into this point where we do things fast, take risk. Who remembers X-34? They didn't fly it because it was going to fail. It's like, Jesus, it's going to go over the ocean and put a hole in the water. Who cares? Go fly it. It's a reputational risk, but you might learn something if you're successful. Anyway, my time's running out.
Thank you. It's done, actually.
Yeah. Okay.
Now we're into Francesca's time.
All right, Francesca, I owe you that too.
Thank you.